So this is the first question of biot Savart law. So the question says that if this is an equilateral triangle of side A, then we have to find the magnetic field strength at center B if it carries the current I. Okay, then we know our general result, and we'll solve with the help of that. So first you have to join this. So first you have to think of the direction. Okay, and we know that because these all directions, these all current produces magnetic field in the same direction, that is inside the plane. Okay, then we can find the magnetic field by the effect of one side, and we can multiply it by 3 because the direction does not changes. So let's solve it. So if you join these two, and we have to draw a perpendicular, because we know that particular special case only acts when it is perpendicular. Then this angle is 60 degrees and this also is 60 degrees. Then our B is mu naught I by 4 pi, and let's call this distance D, into sine 60 plus sine 60. We have to find this D, and because this is because of one side, so we have to multiply it by 3 to get net magnetic field. So we'll multiply it by 3. Okay, so now let's find D. So this is and this is because of so tan 60 is actually equals to A by 2 by D, that is A by 2D, and this equals to tan 60, that is equals to root 3. This implies that D equals to A upon 2 root 3. Now we'll simply put this value here and we'll get a result. So magnetic field is 3, that is we are talking about magnetic field. So 3 mu naught I upon 4 pi A by 2 root 3 into sine 60 plus sine 60. Sine 60 is root 3 by 2, so root 3 by 2 into 2, so this cancels, so this is actually root 3, and we got our result. So this root 3 will go and multiply there, and this 4 cancels by 2, so this becomes mu naught I 3 mu naught I by 2 pi A into 3. Okay, so that's one of the solutions. Let's solve a few more questions. So this is the second question, in which there are two infinite square bent at an angle alpha, and we have to find magnetic field strength at distance t on the angle bisector. Okay, so let's solve it. This is pretty much easy question. So if this total angle is alpha, this is alpha by 2, because this is angle bisector. Okay, now we have to find again the perpendicular this perpendicular distance. This is a perpendicular distance. Let's call this distance m. Okay, then we know that sine alpha by 2 equals to m by d. Okay, then m equals to d into sine alpha by 2. So we got this our perpendicular distance. Okay, now direction, because of both is in the same direction, that is inside the plane, magnetic field strength. So we can simply find, and because both are infinite wires, so we can simply find magnetic field because of one wire, and we can multiply it by 2. So therefore the magnetic field will be 2 into mu naught I upon 4 pi m into this angle is, and we have to take this second angle, that is pi by 2, because this is infinite wire, so this will be at pi by 2. So and this angle would be this, let's say sin theta 1 and sin theta 2. Sin theta 2 is actually pi by 2, we can write it 1, and theta 1 is what? So we can say that theta 1 equals to pi by 2 minus alpha by 2. Okay, so this is theta 1. So sin theta 1 would be sin pi by 2 minus alpha by 2. So sin theta 1 would actually be equals to cos alpha by 2. Okay, because sin pi by 2 minus alpha by 2 equals to cos alpha by 2. So we can write it here 2 into, and this 2 cancels this 4 by 2, so this becomes 2. So this is mu naught I upon 2 pi, and m is d into sin alpha by 2. Okay, and here is cos alpha by 2 plus of 1. So That's again a very easy problem. We'll take few more problems and then we'll wrap up. Okay. So this is the third problem, and this is an infinite sheet which carries current I of thickness L of thickness L, and we have to find magnetic field strength at a distance A. Okay. Now this is actually an infinite sheet. Okay, but it actually is a wire if seen from a different perspective, and we know that in a wire magnetic field strength is, again, this is 4 pi r, and this will be sine theta 1 plus sine theta 2. Okay, so this theta and theta 1 and theta 2 will tend to infinity, so this whole thing will become 2. This is mu naught I upon 2 pi r. Okay, so we'll use this formula to solve this question. So let's solve it. So to solve this, what I'm gonna do is, to solve this, what I'm gonna do is, from this distance I will come at distance x, and I will take a differential element dx. Okay, so if I current flows through L, then di current will flows through dx. Okay, and this di would be, and this di would be I into dx. Okay, this would be the di, and magnetic field here would be dB would be mu naught. This differential element, this will be kind of infinite wire of thickness dx, so and it will produce a dB, that is mu naught into di upon 4 pi x. Okay, and we have to integrate it, so we'll integrate it. So mu naught upon 4 pi, and di is I into dx upon x, and we'll integrate it from a to a plus l, because this sheet begins at a and ends at a plus l, so we'll integrate it by that, and this is a very easy problem, by the way. So, and we get that we'll take I here, and this is ln x from a to a plus l, and now this is very simple. Okay, so this is ln a plus l upon a. That's the solution. I think it would help. We'll take few more questions and then we'll wrap. Okay.